So the question is to obtain the general solution of the Legendre equation. The Legendre equation can be expressed in this form where n is a natural number or 0 at the point x is equal to 1. So first of all, we have to check whether this x is equal to 1 is the ordinary point or it is a regular singular point or what kind of point is that. So to write down this is into the general form, we can write down this is as y double dash minus 2x upon 1 minus x square y dash plus n into n plus 1 upon 1 minus x square y equal to 0. So here we got, I'm not writing now all the details that p of x, the general equation of the differential equation is y double dash plus p of x y dash plus q of y equal to 0. So here we have a p of x, we got it is minus 2x upon 1 minus x square, and qx we will have it is n into n plus 1 by 1 minus x square. Now clearly this p of x and q of x are not analytic at the point x is equal to 1. So we note that p of x and q of x are not analytic at x is equal to 1. In fact, they are also not analytic at x is equal to minus 1. So for that I am going to check for the regular singular point about x is equal to 1. So for that we just check what is x minus 1 p of x. That is minus 2x into x minus 1 upon 1 minus x square, which will gives you minus 2x, minus minus become plus. Let me write down one more step, that is 1 minus x to 1 plus x, and this will cancel out and will gives you minus 1. So that's why it is 2x upon 1 plus x, which is your x minus 1 upon p of x. And another quantity you are looking at that x minus 1 square p of x, which will gives you minus 2x into x minus 1 square upon 1 minus x square, which I can factorize into two things, that is 1 minus x and 1 plus x, and 1 minus x will cancel out and will gives you minus sign. Qx is not 2x, qx is this n into n minus 1, so I should write down that one here. So that is n into n plus 1. So this gives you n into n plus 1, 1 minus x upon 1 plus x. See, 1 minus sign goes out, and that I have adjusted with this 1 minus x. And we note that this x minus 1 p of x and x minus 1 square p of x, both of them are analytic at point x is equal to 1. So here x minus 1 p of x and x minus 1 square p of x are analytic at x is equal to 1. So therefore x is equal to 1 is a regular singular point. Hence this is a regular singular point. Thus we can say that the solution of this equation we can write down in the form of a Frobenius method. So one of the way you can do this is by Frobenius method. That means you can assume the solution is of the form a n x raised to n plus n, and you will do the procedure further. Instead of x, we can have x minus 1 raised to n plus n. So it is better that you can shift your coordinates to the x minus 1, and we can directly convert into the Gauss hypergeometric equation, and we'll get the solution. So that is the better ways to dealing with this solution, to write down the solution of the Legendre polynomial. So what we will do, we convert our equation 1, that is the Legendre equation, that is this equation 1, into the Gauss hypergeometric equation. So let us write that. The equation 1 can be solved using Froben's method directly. It also can be solved using that, but here we convert it into Gauss hypergeometric equation, and that is the better ways to do that. So we know that to know into the Gauss hypergeometric equation, we can see what is the coefficient, what are the factor of this quantity, and from that I will get the value of A and B. So if you have remember, your equation has to be of the form A minus x, B minus x. It has to be in this form, and then from that we can have the value of A and B. So here 1 minus x square is that can be written as 1 minus x, 1 plus x, which will gives you x is equal to 1 and minus 1. So we consider A is 1, B will be minus 1. So the Gauss hypergeometric equation is of the form x minus A, x minus B, y double dash plus some coefficient, some 1 degree polynomial, that is cx plus d y dash plus some constant is there. So whenever the differential equation is of this type, we can able to convert into the hypergeometric equation with the value of A and B we have. So here it is 1 minus x, so these are the two factors we'll have, A 1 and minus 1. So I am considering A is 1, B is minus 1. And due to that, we can assume what will be the solution. This new variable t, it is x minus a upon b minus a. So the value of a is 1 and the value of b is minus 1 minus 1. So it is x minus 1 upon minus 2, which will give you 1 minus x upon 2. So therefore, the value of t will have 1 minus x upon 2, and therefore value of y dash. Now we have to change this equation into the form of t. So the y dash we have, it is dy by dx, which we can write down by chain rule dy by dt into dt by dx. But dt by dx, due to this, it is minus 1 by 2. So this is minus 1 by 2 into dy by dt. Similar manner, we can have the y double dash, which is d by dx of y dash. The value of y dash we got, it is minus 1 by 2 dy by dt. Here again I can use the chain rule. So this is minus 1 by 2 d square y by dt square into dt by dx. But again dt by dx is 1 by 2, minus 1 by 2. So this will be minus 1 by 4 d square y by dt square. So y double dash is this 1 by 4 d square y by dt square. T is x minus, sorry, t will be 1 minus x by 2. So this is 1 minus x by 2. So from that we can have this value of 1 plus x. The value of 1 plus x. So from this I want to calculate 1 plus x and also 1 minus x. So I can have the value of 1 minus x square. That is the things we need to substitute into this equation 1 minus x square, the value of x. Y double dash and y dash we already get in terms of t. So now we need to have this 1 minus x square and 1 minus or the value of x. So if you simplify this, this will give you 2t equal to 1 minus x, and that will give you x is equal to 1 minus 2t. So 1 plus x will give you 2 minus 2 plus 2 minus 2t. 1, what I'm doing. So 1 plus x will give you 1 plus 1 minus 2t. So that will be 2 minus 2t. So that is 2 into 1 minus t. 1 minus x, or I can say 1 minus x square, is 1 minus 1 plus 2t. So this will give you 0 plus 2t. So this is 2t. So 1 minus x we can write down, it is 1 minus x into 1 plus x, which will be 2t into 2 to the 4t into 1 minus t. So this is, we can have as a 1 minus t square. Now substituting this all the values into the equation 1. So hence the equation 1 becomes what was the equation 1? We can have it is 1 minus x square y double dash minus x y dash plus n into n plus 1 y equal to 0. This was the equation 1. 1 minus x square we already calculated here, that is 4t into 1 minus t. Is 4t into 1 minus t. Y double dash we already have calculated, that is 1 by 4 t square y by dt square. Minus x, the value of x is 1 minus 2t. 1 minus 2t. We have to see also what is the equation. This is 2x is there, so I have forgot that 2 there. This is 2x into y dash, so this 2 is a forgot. Y dash we have calculated, it is minus 1 by 2 dy by dt. So it is minus 1 by 2 dy by dt plus n into n plus 1 y equal to 0. So this equation I may write down or rewrite as therefore t into 1 minus t d square y by dt square. This 2 will get cancelled and minus minus become plus 1 minus 2t dy by dt plus n into n plus 1 y equal to 0. Comparing this equation with the hypergeometric equation. What is the hypergeometric equation we can have? So comparing with Gauss hypergeometric equation, I am writing in short now, which will be x into 1 minus x y double dash plus c minus a plus b plus 1 x y dash minus ab y equal to 0. So if you compare with this one, you will have the value of c is 1. The value of a plus b plus 1 is 2 and the value of AB is n into n plus 1. We get the C equal to 1, A plus B plus 1 equal to 2, and AB is minus of n into n plus 1. Because this is of minus sign, here we have plus. So this will gives you A plus B will be 1. And now we need to have this two equation, that is A plus B is 1 and AB is n into n plus 1. And I want the value of A and B. The value of C already we have. So to get this value of AB, I just take the square of this quantity, that is A plus B square minus 2AB. This will gives you A minus B square. So if A plus B, the value of A plus B is 1, minus 2 into n into n plus 1. That minus minus become plus. But how we can have that? If A plus B is 1, AB is this. Now I want the value of A and B.
Sir, A will be minus n and B will be n plus 1 directly from this equation.
Okay, that also can be done directly from this equation, means you substitute. All right, we just not doing this. So we can have, how we'll do that?
Sir, taking A equals to minus n and B equals to n plus 1 will get A plus B equals to 1.
But the question is why you have that thought. A plus B equal to 1 and AB is minus of n into n plus 1. Yeah, you can say that here A is minus n and B will be n plus 1. Then you will have a solution for this, definitely. But my question is, why you will have the thought of A equal to minus n? That can be calculated using this manner. That means you substitute the value of B from this here and you solve that one. Or value of A from this, you will substitute here, you can have this. You have quadratic equation and from that you will have this solution. That is what is the equation you will have? It is A will be 1 minus B. You substitute here, that is A into B into 1 minus B equal to minus of n into n plus 1. So this is B square or minus B square plus B equal to minus n into n plus 1. So if I factorize, this is B square minus B, then minus n into n plus 1 equal to 0. Then you can have this B square will be minus n plus 1 B minus nb. I can write down plus nb minus n into n plus 1. equal to 0. So from this, B is common out. And from this, N is common out. So we'll have B equal to N plus 1, or B will be minus N. These are the two possibilities. If B is equal to N plus 1, A will be minus N. And B is minus N, then according to the B is N plus 1. So this is the things we call. So hence we have the value of A is minus N, B is N plus 1, and C will be 1. So according to the solution, so it is only one solution is possible. Why is the only one solution is possible? Because we note that the exponent of Gauss hypergeometric equation are M1 is 1 and M2 is 1 minus C. These are the exponent, because into the solution of hypergeometric equation what we will have, it is f of a, b, c, x, c1 into a, b, c, x plus x, c2 into x raised to 1 minus c, f something a minus b, b minus c, and all sort of things is there. So these are the exponent. The one of them is 1 minus x, another exponent is x. So if these roots are same, then it will be a linearly independent solution. So here the M1 is 1 and M2 is 1 minus C, and the value of C is 1, that is 1 minus 1, which will be 0. And then what we have is M1 minus M2 is 1 minus 0, which is 1, which is an integer. And since it is an integer, it's while you're doing the Frobenich method or Frobenich solution, only one linear independent solution is possible. You know the procedure for that. Okay. So that's why we can say that, so it has only one Frobenich solution, and it is Gauss hypergeometric series, which is y1 equal to f of a, b, c, and x. So what is the value of A? It is minus n. The value of B is plus n plus 1. The value of C is 1, and the value of x is p. This is the solution we can have. Now to find out the another linearly independent solution, so what we have to do is to find another linearly independent solution y2. Let y2 will be the procedure, as you have remember, we can take it y2 is equal to vy, where v dash is 1 by y1 square e power minus integration d dt. So what is the value of p? The value of p we can have from this, it is 1 minus 2t upon t into 1 minus 2t. That is, we get when you divide this by this equation. I can call it, this is as the equation 1 or 2 or whatever the number, let's say that is 3 if I have not forgotten anything. So this will gives you from equation 3, Pt is 1 minus 2t upon t into 1 minus 2. So then we can calculate what is the integration of p dt, which is integration of 1 minus 2t upon t into 1 minus t dt. So you can just observe that this is 1 minus 2t upon t minus t square dt. So the derivative of the denominator is here in the numerator. So it is of the form f dash of t upon f of t dt. So that integration of this one will be log f of t, mod of f of t. So this will be log of t minus t square. And the limit, so this is actually a log of t into 1 minus t. Now, in the solution, you will have e power minus of this. So let us try to calculate that e power minus of integration p dt. So that is e power minus of log t into 1 minus t. So that will gives you e power log of t into 1 minus t power minus 1. This will gives you 1 over t into 1 minus t. Due to it is e power log of e base something. So that is gives you this. And hence this v dash we will have, due to this v dash is 1 upon y 1 dash e power minus of p dx. So e power minus of integration of p dx, we have calculated this. So it is, will gives you u2 dash, it is 1 minus y1 square e power minus of integration p dt, which is 1 minus y1 square into t into 1 minus t. And this I can write down into this form. It is 1 minus y1 square into 1 minus t into 1 upon t. Now what is the value of y1? The value of y1 is, we have calculated this. That is, this is the value of y1. And we note that this is the series of in terms of t. So we can say that this y1 is analytic at t equal to 0. And what is this series? It is 1 plus summation something. What is y1 of 0 is 1. y1 of 0 is 1. That is also we can say. So what we can say here, we note that this y1 is equal to f of minus n plus 1, 1 and t is analytic at t equal to 0, and y1 of 0 is 1, which is non-zero. Okay. Hence, this is non-zero function. Mean to say this y1 is non-zero function, and this is also, it is a non-zero. It is also analytic at the point t equal to 0. So hence, this function 1 upon 1 minus t square into 1 minus t is analytic at t equal to 0. So if it is analytic at t equal to 0, we can able to write down into the series solution. So we can write, that is 1 upon 1 minus, sorry, 1 upon y1 square 1 minus t equal to b0 plus b1t plus b2t square bt3 cube up to so on. So thus V dash will be 1 upon 1 minus 1 upon y1 dash square 1 minus t square, which was y dash is into 1 upon t, will be b0 by t plus b1 plus b2t plus b2 b3 t square and so on. So I want actually the v, so that is integrating. V will be the integration of this quantity will gives you log of t plus b1t plus b2t square up to b3t raised to b t square by 2, this is by 3 and so on. So integrating this whole quantity. So finally you will have y2, which is v into y1, which will be y1 into the value of v we have calculated, that is this b0 into log t plus b1t plus b2 into t square by 2 up to so on. And we call it this is as 4 or whatever the number. Which number it is this? 4, let's say 4. Hence the general solution is y equal to y1 c1 y1 plus c2 y2, which is c1 f of minus n plus 1 t plus c2 into y2. The y2 is this, y1 into y1 is this, which is I have, so I just write down f of minus n into n plus 1 t into this whole quantity b0 plus log t plus b1t b2t square by 2 and so on. But what is the value of t we have calculated in terms of x? So the value of t in terms of x we have, it is this 1 minus x by 2. The value of t is this 1 minus x by 2. We can write down that value here, and hence we got the general solution will be y equal to c1 f of minus n plus 1 minus x by 2 plus c2 into the same thing f of minus n plus 1 minus x by 2 inside bracket b0 log of t is there, so instead of log of t it is 1 minus x by 2 plus b1 1 minus x by 2 plus b2 by 2 1 minus x by 2 square and so on. So this is the actually the solution of a Legendre polynomial, which is the required solution of Legendre equation. And we should note that this solution is the bounded solution due to this, the term is not bounded solution due to this term. If you want that this solution will be bounded, we need to have the C2 will be 0. Okay. Because of this log term is there, and log function is not a bounded function. So if you want that this solution will be bounded function, if this value of C2 will be 0, if and only. So that is as a remark we can write down here that the above solution is bounded if and only C2 will be 0. Now, what is the Legendre polynomial comes out of this? If this n, you just expand this quantity and that will give you a Legendre polynomial. That is the solution and which can be denoted as Pf. We will discuss that is in the next lecture. So till then, I will stop here. So in this lecture, we have discussed the solution of a Legendre polynomial about the point x is equal to 1.